The aim of this project is to design and implement DFT magnitude spectrum based letter discrimination by finding dominant frequency peaks for the letters A, B, C, and D. Assume sampling rate of 16,000 Hz for recording sounds of A, B, C, and D and suitable block diagram. Automatic discrimination of speech signal is an important tool in many multimedia applications. The amplitude of audio signal varies continuously with time. In particular, the amplitude of the unvoiced segments is generally much lower than the amplitude of voiced segments. The letter symbols used for the writing are not adequate as the way they are pronounced varies. So it is impossible to tackle the audio classification problem. So we are using the discrete time Fourier transform method to find the frequencies of the audio. By moving forward, we will see the solution approach for this. First, the audio is recorded in the Audacity software and sampled at the 60,000 Hz frequency. Later, we will convert the time domain spectrum into frequency domain spectrum by using the discrete Fourier transform. Later, we will find the top 5 dominating frequencies. By taking the average of the frequencies, we will fix some reference value. By doing all the above steps, we can easily discriminate the letter, audio of the letter. Let us see the discrete time Fourier transform. In time domain, representation of the digital signal describes the signal amplitude versus the sampling time instant. But in many practical applications, signal frequency content is very useful to perform frequency analysis on a discrete time signal. We convert the time domain sequence to an equivalent frequency domain representation. The discrete time Fourier transform of a sequence is given by capital Xk is equal to sigma n is equal to 0 n minus 1 x of n e power minus j 2 pi kn by n. The capital N is the number of samples and small n is the current sample and capital K is the current frequency where k varies from 0 to n minus 1. Small of x of n is the input discrete sequence and capital X of k is the discrete Fourier transform. To find the frequency reference for the dominant peaks, I have recorded some samples of the audio sounds of letters A, B, C, and D and found the average of the dominant peaks to get the reference frequency to compare with the new audio. Here are the values for that. Sampling 1 dominating frequencies, sample 2 dominating frequencies, sample 3 dominating frequencies. For audio signal A, audio signal B, audio signal C, and audio signal D. Later, we'll move to the MATLAB code. Audio read is a function which reads the audio signal and returns the total sample sampled at the sample rate, that is 16,000 Hz in our case. Here x1 is the number of samples that we will get after we read the audio file. Here n is the length of the x1. T is the time from 0 to n minus 1. Here we are writing the code for finding the discrete Fourier transform. Here we are initializing the array to store the DFT of x1. Here it is the for loop running from k is equal to 1 to n and from n is equal to 1 to n. We are adding the values like formula sigma k is equal to 0 to n minus 1 x of n e power minus j 2 pi by n. As the frequency is not centered at our origin. We are dividing it into positive and negative side. So this is the frequency range. And to shift the DFT according to the shift in frequency, we are using this FFT shift function. Later, we are plotting the graph between frequency and absolute octave and shift. After that, for finding the dominant peak frequency, we are initializing an array to store the dominant peak frequencies. Here, it is the maximum peak function is the user-defined function which returns max k amplitudes and their indices. Let us look at this function, maximum peak function. It is the user-defined function to return the top k magnitudes along with their indices. Here we are initializing some flag variable, and this is the index array to store the indexes. Here we are initializing this indexes, and here we are running one loop which sorts the x and shifts the indexes accordingly, like you can say the brute force approach to sort the values. Like when we give the random signal also, we are able to calculate the result. What we are doing is from the above code we will get some reference values, so we are storing these reference values like this, like A reference, B reference, and later we are initializing an array to store the dominating frequencies. Later by calculating the error and by considering the minimum error, we will able to find the audio of the which letter it is. Let us go forward to the GUI design of this. This is the code for the GUI design. If you run this code, we will get the interface like this. Here we can, this is the push button, browse audio files. We can get the file from our desktop. So that we will get the output like this. First we will get the time domain plot of this, and after that discrete Fourier transform, and also the top 5 dominating frequencies, and later finally we will able to identify the sound of the letter. Let us see the results obtained from the MATLAB code. Here are the results. This is the frequency spectrum of the A letter. These are the top 5 dominating frequencies, and similarly this is the frequency spectrum of B letter, C letter, and D. The conclusion is the difference of the dominating frequencies we got is it is stored in an array. Similarly, the B reference values, C reference values, and D reference values. Observation, the main observation we will observe from this graph is for audio A, we use a DFT to plot the DFT spectrum and then found the dominating peaks are like this. If you calculate the error of these peaks with the reference value of audio A, which is less when compared to that of other audios, that is we got 48, but the error of the other audios are like this respectively. Similarly for audio B and for audio D, later we will choose the least error and we can discriminate the which letter it is. Conclusion: the number of computations required for calculating the DFT of an input sequence xn containing n samples is n to n. Here one n represents the number of multiplications and the other n represents the number of additions. So it requires n square commutations. So the time complexity of the algorithm is O n square, which is quite time consuming for normal computers. And also, so it is better to use the fast Fourier transform, which has the least computational complexity. In MATLAB, it has a direct function FFT. We can use that for the faster computation. And also, we have the function called maxx to find the dominating peak directly. But I have wrote the code for this, but it takes lot of time than the inbuilt function. So I think it is better to use that inbuilt function maxx to find the dominating peaks. So here I am concluding this. Thank you everyone.